Today I'm going to be showing you how to fine tune a model on HuggingFace. So I'll be showing you the models that are available, the data sets, as well as this thing called HuggingFace Spaces, which is basically a way to showcase what a model can do. We'll actually be uploading the fine-tuned model to your HuggingFace account by the end. I'll walk through the training script line by line and help you set up your local environment. So to get started, HuggingFace is basically, think of it like GitHub, but for AI in a sense. So you have the ability to host multiple different models. You have a whole host of data sets available for you. You can host your own data sets. You can create your own. There's basically models and data sets that cover multiple different domains. You have text to speech, text to text, all different kinds of models for vision, all different kinds of solutions here. I do want to show Spaces. Spaces is kind of like a way to basically showcase what is available with the current models that exist. So you have some where they can like animate images. You can upload an image and change like the background, or there's like a bunch of different options here. Audio solutions, and they're basically like little previews of the underlying functionality of what the model is trying to do. A lot of these guys, they'll host this on here to kind of showcase or preview what's going on. And then usually like the underlying site has some kind of an API that you can use if you want to like integrate it into your application or something like that. So to get started, we're just going to go to the model that we're going to be using today, and that is going to be under Google, and it's going to be the T5 small. There's multiple different model types. We're just going to be doing the small just because it's going to be the fastest for training. So just so you understand, we're just going to go through the steps of training. Later on, we'll focus on actually doing like a legitimate optimization using cloud run GPUs, but I'm just only doing small model, small data set, and a very light training just to show the underlying process of actually fine-tuning a model. So this is the model that we're going to be running with. And then for the data sets here, let's see. We're going to be using the SAM-SUM dataset. It's a very simple dataset. It's basically just a bunch of dialogues and then the summary for that dialogue. So here you'll have, like a text conversation, and then within that, on that same row, you'll have the summary. There's about 15,000 of these. So if you think about it, we can get this basic model right here that just has basically simple text generation. Think of it like a very lightweight version of ChatGPT or something like that. And then you can feed it a data set and teach it how to respond if it's given certain information. So what we're going to do is we're actually going to feed it each piece of dialogue here and the summary. And what's going to happen is the model is basically going to attempt on every single step or iteration that I show, the model is going to attempt to provide an output. And based on how close that output is to the actual summary output, the model is going to tweak its weights. And it's not going to tweak the entire model. It's just happening basically like on the end, I guess. So that's like about how simple I can explain that whole concept. But let's go ahead and we'll jump over to the code. All right, so we're in VS Code now. We're going to be using the train.py function. Just ignore the rest of these. These are like just for testing and different kinds of things I was trying to sort out with like running training within the cloud and everything. So we'll just focus on the train.py for right now. Later we can explore actually running a GPU in the cloud. The way that this is going to work is we have this terminal right here. I'm going to set up the local environment so you can see what that looks like, and we can make sure that we're running on a clean environment, because my main computer still has Python installed and all that stuff, and has a bunch of libraries in there that are completely irrelevant to this. So to get started, we're just gonna set up a virtual environment. So it's Python 3-m venv, and then we're gonna store that in the .venv directory. So that's virtual environment. Oops. Okay. So what I need to do to actually load this environment, we're gonna run source, and then you're going to specify that directory venv /bin/activate. And now you can see we're running within this virtual environment. So if I run a pip list, you actually see there's only a couple packages installed, and these are actually like base packages. So what I can do now is I can actually install the libraries within this requirements file. And this is just a clean way to specify what actual libraries are responsible for this specific application. So I bet you on your computer, on your main setup, you have a bunch of random libraries installed from testing things, getting things running. This environment's only gonna have these libraries that I'm specifying. So we'll run pip install, and then it's -r requirements.txt. So we're specifying that requirements file. Once I go through this, it's going to install every single one. So pip install this, pip install this, pip install this. It's going to walk through everything. Okay, so within HuggingFace, all we have to do to get the access token is go to your account, create one. If you don't have it set up, it's free. Go to either settings or access tokens. Both go to the same place. Basically, go to settings, and then on the menu, you'll hit access tokens right here. You can go ahead and create a token. This is very similar to GitHub. I'm just going to go with write access because we're going to be writing when we finish fine tuning our model. We're going to push that. So I'm going to go Mac local or whatever you want to name it. Doesn't really matter. You create your token. You can copy this guy, and then we'll set this up within your CLI so that when you run your application or when you run this fine tuning process, it has that access key. So those libraries are installed now. So if I run a pip list, we'll see libraries are all right there. To set up that HuggingFace token with your local environment, you need to run HuggingFace-CLI space login. And once you run that, it'll prompt you for that token that you grabbed from your HuggingFace account. So let's run through this code here. So we just have some imports, basic imports right here. This is PyTorch. This is HuggingFace's datasets library. And then we have the transformers library. We're just importing a few different resources from HuggingFace. At the top here, these are defined by us. They're just basically just a bunch of constants to specify the dataset that we're using, the model that we're using, and then where we're going to be outputting this model. Within here, there's some configuration options, so similar to how we did this, we can actually, with the token, we can actually specify certain values to kind of overwrite different configuration options, like the number of epochs or something that we want to do. So right now, what's going to happen is it's going to run through the data set, and the epochs is like basically, it's like an iteration through the data set. So if I say I want to only train on 500 of the rows within the data set, and I specify 8 epochs, it's going to do 500 steps 8 times. We can ignore that for now. Here's the actual main function. So just a few things that we have here. We're going to be loading in the data set. We're going to be adding the task prefix. So for each individual row within the data set, we're adding a tag at the very beginning of it with a task. And the task is basically just summarize. And then during the pre-processing, we're appending that task, the summarize prefix into there. And then for these, where it says labels, we're just reducing the padding. So we're specifying a -100 because that gets ignored within our loss function. So what happens is if there's empty space, the AI is not getting, I guess in a sense, kind of corrupted, I guess. It's just not using it for the grading for the actual training process. All right, and then we have some additional pre-processing here. We're setting up our collator and then just checking if the GPU is available. Within here, we're just specifying a few different arguments. You can see a lot of these are the constants. This is going to get passed into the trainer so that when we execute the training, it uses these arguments. These are all basically like the default. There's nothing really special besides like that epoch adjustment that we did. But as you go in deeper and deeper into training, this is where you start tweaking these guys to, you get better results or something like that. All right, so here's our trainer. It's just basically putting everything together. So we're specifying our model, our arguments, our data set, our tokenizer, and then our data collator. And then all we have to do right here is just execute the trainer. Once that's completed, we'll push it to HuggingFace, and this is where it's going to use that access token that we set up. So all I have to do now is just run Python train. We'll hit that. It's going to hit some pre-processing. So it's going to hang for a minute. Once it shows the graph, we're actually running through the training process. Okay, so we can ignore these warnings for now. What we really care about is down here where we see this progress bar. It doesn't really look like a progress bar just yet because we're only on step 10 of 1300. So there's basically 1300 steps in this training right now, and it's going to run through this process 3 different times. And every single time it's going to reevaluate the actual weights in the model. So long story short, we have HuggingFace, which is like GitHub for models, datasets, and demos with the spaces. And then we have this fine-tuning script that runs on Google's T5 model and the Samsung dataset. And then we'll run this with just one command, and it's going to train the model and upload that back to HuggingFace. And then we can later on, we can build a space using Gradio. So, and I'll include this in the actual repo for this, but within your spaces, you can have like an example where it actually shows your model running. So right here we have the base model, and then we have the actual fine-tuned model here. And then we can specify or add in like just like a basic dialogue example and actually test this guy. So we'll go over to Samsung. I'll just grab one of these. Okay, so we can see that this just ran, and we have our base model, and then we have our fine-tuned model. You'll see that the results for it are actually a little bit different because the models are actually running off of different weights. Now, keep in mind, this was off of a very light training. This wasn't actually built to be actually legitimately functional right now. We're focusing mainly on the underlying components of this. So I'm not gonna sit here and we're gonna spin a bunch of GPUs and sit here and run this for an extended period of time. This is just showing the process of getting your environment set up, getting through the training process, pushing a model and everything. You can see right here, we have our T5 Samsung demo, and it shows right here, we have our base model is that Google T5, and then this model was fine-tuned. So at this point, the next step is going to be running an actual full-scale training process using GPU-backed clusters within the cloud. So we'll be running some GPUs in the cloud, doing a full training set, doing an actual set of epochs to get this model into a better position. We'll actually be changing the model that we're using that's a little bit more beefy. Right now, I'm not sure if it's even picking up, but my fan on my laptop is starting to kick on just for the training right now. So I'm gonna kick that off. But we're gonna be running that all in the cloud, and I'm gonna be providing a way to do this basically near free. You can do it for free if your computer is just not capable. But in order to get the actual premium GPUs, you're gonna have to shell out just a little bit, nothing super crazy. But I'll show how to spin all that up, and I'll provide launch scripts and everything so that you can just spin it up, run your training, and then kick it off so that you're not just accruing cost. But that'll be on a later video.